So I spent a bit more time looking at schematics and actually adding some pinouts of things here to look at. I couldn't find the enable pin numbers on the buffer down here for the RAM back to the Z80, and that's pin 1 and 19. I need to make sure those are being clocked. We've got these drivers right here, which is this set of driver gates that drive each one of the digits. And then we've got the transistor drivers here. And I wanted to make sure, let's see, pin 3. So the transistors are in the correct orientation. That's why I've got the little thing on here. So it is emitter base collector in the silkscreen. And pin 1 is the emitter. Yep, those are in the right orientation. There was a comment in the manual or a picture of a different body style. I wanted to make sure that the silkscreen made sense. I'll be able to look at these to see if anything's clocking on them. If I'm getting outputs on pin 5 or pin 3, that would indicate that something else is causing these not to light up. But really at this point we can apply power again. So turn the power supply on. Let me enable the output. It's drawn 290 milliamps. We're in that mode where we're simply looping on no ops. So we should see, oh, I've got to reset to get the system running first. So we're seeing activity on all the address lines. On pin 1 here and 19 I should be seeing enables. So that says to me the enables are happening to get the RAM onto the bus. For the 2102 chip enable is pin 11, 14, where's that 12, 8, 9, 10, 11, 12, 13, 14, 15, 13, 16, 15, 14, 13, 16, 15, 14, 13. So it would be requesting data from these. That's the chip enable. I should be seeing activity. Activity. This would be the read. It's never actually trying to read. See, no, it is high. It appears to be stuck in right. That may be the core problem right there. Pin 3 is, oh no, read is high. So read high, write low, and that's high. So that is read. That I guess makes some sense whenever trying to write. Address, 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 address. Chip enable. Actually, that's VCC and that's ground. That's an address pin. Address pin. Address pin. Chip enable we looked at. Data out should have nothing. Data in's just sitting low because the data bus is tied to ground. So that makes sense there. Let's come down to the 8316. We have A6 to A1, A6, A5, A4, A3, A2, and A1. Those make sense. A0. 3 data lines. Actually, that would be A0. And then 3 data lines, which are just being held to ground currently. In VSS, we should have +5 VCC. A8's clocking. A9's clocking. That chip select is held high. That chip select is being used and it's an active low. There is A10. Chip select 2 is just held low. I think it's tied directly to ground. Data 7, data 6, data 5, data 4, and data 3. So all the signals there make sense to me. All four of the data lines here should be grounded to the CTC, and they are. There's a clock down here that is active. There's a chip enable which is clocking. I'm not sure why that is. That may make sense. Reset is of course high. Chip select 0 and chip select 1 are clocking. Okay, that didn't make sense. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Why is clock trigger 2 high? Unless it's being pulled high by something. Would be +5, and then 4 data bits, and 1 should be clocking, and it is. Interrupt isn't happening. So I need to go look at clock trigger 2, 2, 3, 4. We then got +5. I want to look at pin 21, clock trigger 2. See if I can tell why that's high. Get to the schematic. Put on glasses so I can actually read the tiny words in the schematic. Pin 21 is an input. 22 is an input. 23 is an input. 21 is an input. CT2, I don't know where that's actually coming from. I haven't done a lot with the Z80 CTC, so I don't really know how it's used and decoded, etc. in the system. I'm going to assume for now that's okay. And I guess we'll start to put stuff back in. So, power's off. Where'd that wrap tool end up? There should be, there's what I'm looking for, my unwrap tool. Let's just pull this off. That pulls the grounds off of the data bus. We can now put the ROM back in. It doesn't need the PIO to access the ROM. Ow. RAM back in. There's a couple things I'm going to test here. I want to look at what address lines are actually seeing activity. I want to look at the signals that generate the IO read and IO write that would be being used, I believe, to talk to the PIO. So that should be enough, in my opinion, to get us a running system. without displays. I don't have the PIO or CTC in place. And I believe the CTC actually generates the interrupt that makes it refresh all of that. But what I want to see is we should see, I got a reset. We should see activity start. 3, A4, A5, A6, 7, 8, 9. I expect those to be active. I would expect A15 to be low. 14's clocking, 13's clocking. I think this kind of makes sense to me. A0 to A10 would be talking to the ROM, and address space above that would be the RAM. We had already kind of looked at ROM and RAM signals, the enables. We can look back in the schematic. I have not memorized what those are. RAM is on 4. 8 is the ROM. And 4 would be the RAM. And I would expect these others not to be doing anything because we're not talking to that address space. This really looks to me like it is executing code out of the ROM. And again, RAM. So we're seeing RAM and ROM access in the address spaces where those live and nothing else. So that's a really good sign. That does say to me that the CPU must be running at this point and reading the ROM and using the RAM. So where to go next? I guess I need to put a PIO in. Have I just been chasing the wrong issue this whole time? PIO is in. Calendar timer is in. Power back up the board. Reset it. We should see a very similar thing, A15. So let's go ahead and look at pins 1 and 2. There's no activity happening on those. Don't even see a pulse. Or the other two were 6 and 7. If it was trying to talk to the display, I would expect one of those to be doing something. '28, 27, 26, 25. 24 is +5. None of the clocks are doing anything. There's clock 2 the part. Chip enable not is always high. Well, it does see the reset, so it does get talked to momentarily. It looks like. It gets selected briefly at reset. Here's the reset signal itself. Chip select 0 and chip select 1 are clocking. Let me find the I/O port decoders. in the schematic. I spotted these earlier. Need these glasses. It is U39, pin 6 and 11. U39, pin 6. Eight, 9, 10, 11. Let's see, 11 is IO write, and 6 is IO read. So if we go to U40, pin 6, that's the keyboard enable, so it's attempting to read the keyboard. Pin 3 is the digit latch. Does anything happen on reset? No. Here we go again. No clue what they're barking at. And segment latch is on pin 11. So it's obviously not getting to the point it's trying to write to the displays, because the digit latch and the segment latch are not happening, even though the keyboard select is. Pretty sure I don't have a, oh, there's got to be a CTC in here. We've got so many other chips. Oh yeah, CTC, lots of CTCs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've got 13 here in the box. I have plenty. Let's pull a couple of these out and we'll just swap it out. The container is all my Zilog pulls from over the years. So I've got both the Z80 and a Z80A CTC here. Let me turn off the power. I doubt this is the issue, but I'm going to give it a shot. Like I say, I'm convinced the core computer group is running. It's just not, for whatever reason, trying to talk to the displays, and I believe that happens via one of the timers. Around 590 milliamps, and we're not seeing, again, any traffic. I'm hitting the bases on these just to see if there's any sign of multiplexing happening. And there's just not. So it becomes more interesting here. 40 pin 6 again is that keyboard select. U40 pin 3 and 11. So pin 1 is always high. And pin 1 goes off to IO write, and there's no IO writes happening. We determined that before I My right is U39. Pin 11. Right here, there's no rights trying to happen. Pin 12 and 13 are what drive it. 12 is clocking. 13 is clocking. That's interesting. Yet it's always high. C pin 9, 10, and 11. 8 is memory right. I suspect if I reset, we see some activity there where it does some initial writing into the system RAM. So that makes sense. We know memory read is firing. We looked at it before. So really the question becomes, why is IO write not firing? And pin 13 and 12. 12 has activity on it. 12 comes from write. And 13 comes from IO request, pin 20 on the Z80. So we have IO request clocking on the Z80. And that signal should be going to U39, pin 5 and 13. U39, pin 5, and pin 13. Okay. Now I'm confused. So they're both clocking. I wonder if we've got a bad chip here. That is, I believe, a 7432. This one's got really dull legs. 74 LS. I'm pretty sure that's a 32. I'm going to grab a newer LS32 and pop it in there. And 74 LS32. In you go. Reset. So this tends to say it's something in the timing then. The signal's on the other side. Or potentially that pin is shorted to ground, or +5. What I don't know is the activity on these two. Are they in? What's their relationship to each other, such that an OR gate would actually see something happen? When we reset, we should start seeing. That is still high. Why is that high? 9, 10, 11. Goes to pin 1 on the digit latch. It does come up here where I saw it go to pin 1. Oh, geez. Where did that shoot off to? Power is off. We have a short between VCC here and pin 1, and we shouldn't have a short there. So that's pin 1 on U40, which would be the digit latch and also feeds the selection latch. So why do we have a short to pin 1? Where is that short coming from? Should have continuity there, but we shouldn't show a dead short to VCC. So I suspect that's our issue right there. We just got to figure out what's causing that short. So sorry, phone call there interrupted us. So I've been looking closer at the schematic. And the I/O right, you probably can't see this, but the I/O right comes from pin 11 of U39 and goes to pin 1 and pin 13 of U40. And that signal is shorted to VCC. And I'm guessing that's happening because pin 13, it comes to pin 13 and 14 as power. So I'm guessing on U40, that would be the most logical place for there to be a short. Is there was a short between 13 and 14, and I sure don't see anything looking at the board. But that would be the logical place for there to be an issue. I don't see anything up under the socket. But what I am going to do is I'm just going to heat up. Let me clean the tip off. I'm just going to heat up the solder on pin 13 and 14 and just let it reflow. And if there is, say, a short up underneath the socket, sometimes that's enough to clear it out. Nope. That would be the most logical place for there to be a short. That also goes to pin 1 on that package. And pin 11, and again I can see up underneath the socket. It doesn't look to me like I see a short. Well, at this point, I guess my next step is I'm going to remove those two sockets so I can look closely at the PCB. As soon as I can actually get the desoldering gun at hand here, and I'm going to go ahead and remove these two sockets. So I would expect that socket to be loose. Oh, there was a little solder ball up under there that may have been the issue. I need to flow some solder to the, I believe was ground here. We'll just use the tip to do it, or the soldering gun to do it. Let that heat up a little longer. That looked like it cleared out. Oops. And there's the trace. It goes from pin 11 to 1 to 13, just as we'd expect. To 1 to 13, and it's still shorted to VCC. How could it be shorted to VCC? Eight, 9, 10, 11. It's just floating copper on this side. One also goes off to, what the heck? Okay, that is different than what the schematic shows. Oh no, it goes off, oh, U37 pin 13 as well. What do you want to bet the short? So it comes up to an inverter here. Oh, crud. How many times in video have I said, well, there's another part on the floor? Hard to reach. So it also comes up to this inverter package here. I should have looked closer at the schematic before, and that's a 74 LSO4 to pin 13. Oh yeah, there's a huge solder bridge right there. Is that not supposed to be there? No, it wasn't. That big old bridge, I had noticed it, but it looked like it was meant to be there. So we can solder this back up. I'm going to get two fresh 14-pin sockets. So first off, let's, yeah, this is going to be fine now. Let me get two fresh 14-pin sockets. We will replace those once I spot the sockets. Oh, glasses. I'm not going to reuse the old sockets. One of them I bent the pins all up on, getting it out. And the other one, you know, has been soldered in and pulled out. And it would be pretty easy to have a little solder ball or something and create a solder bridge that I really don't want to have. So I'll just replace those with two new sockets. Yeah, getting a little harder to do here because we've got so much stuff mounted to the board. You know, like I said, I'd noticed that solder bridge before. It just looked like it was supposed to be there. It was so perfect. I just took it as gospel. Looking at it, I should have checked. Well, we have a shot at working now. This should fix the I/O write issue, which means it should be able to write to the display. If this does fix it, the only gear we used was a logic probe and a volt-ohm meter. It's a nice meter, and it's a nice, well, it's an old logic probe. It's a Tandy one that I've probably had since the 70s. So it would be very appropriate to this build. I've got much newer ones that have more features, but the one we're using is very appropriate. There should be that's the 7432i. There's a 7432 that goes right here. That's the 04 that goes at U37. There's a 7432 that goes right here. So that's back to all the original logic. Well, nope, no longer shorted. No surprise. So let's reapply power here. Don't have enough room. This is not the best way to bring power into this board. It's just what I'm doing. Okay, we've got power to the board. We'll go ahead and hook the logic probe up. We'll take this solder and move it out of the way. We don't need it creating a short, and hopefully when I reset the board now, we will see a dash on the 7-segment displays. So reapply power to the board, reset it. Ah, yes, we're running. So that single dash right there is the indication that we are up and running. So that one solder bridge was the issue that was keeping the displays from working. I'm sure you're not going to be able to see this well in the schematic, but the I/O request and write are ORed together here to create I/O write. And then I/O write goes to 2 more OR gates, and depending on whether it wants to write to the segment or the digit, it gets routed through 2 more OR gates, and the output to those 2 OR gates was not working. It was stuck high, and that was because ultimately the output of U39 here, this whole I/O write chain here, or down here, I/O write chain, was shorted to VCC, so it couldn't actually do anything. So I don't really know how to use this at this point. Register I has a 6 in it. No, that entered a 6. Register examine. It is responding to the keyboard, however. And that's what I was looking for. Cassette load. So there's nothing for it to load. And I think the load LED is kind of a modulation thing. So let's see, let's go to 0000, do a memory examine. And let's look at the listing and see what's supposed to be in memory. Boy, getting to address 0, this listing is long. There it is. So there should be a 31C023. There should be C023. We should then find a C39F00, C39F00, ED73, zero, 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 8. 456. I obviously don't know what I'm doing. 0000 memory examine. We've got the 31 C023. We've got a 39 9F00. 0, 1, 2, 3, 4, 5. We then have nothing until we get to address 8. So we should have FFs. At address 8 we have an ED73FF. 8, 9A. Interesting. Address C is an F5, so it doesn't agree. Ah, okay, so load the stack pointer. Okay, so that's what that was. That's why it didn't match up. 1803. Sweet. Zero, 7, 7, F. So I can't do that. Some of the key switches aren't down as tight as I like them to be. So let's go to 078F, 0784 actually, and do a memory examine. And there's an E6 there. E680B4, E680B4. Yeah, we're able to read the ROM. We're seeing expected bytes from the ROM. It's reacting to the keyboard. We really do have a running system at this point, so it looks to me like everything here is good. I have an image for 2716 for Prom 1 down here that has 3 little programs on it for the system. I need to get a 2716 programmed up. And then we'll play with that, but to really recap, actually there's a couple of things we can do here. I'm going to swap back in the original CTC chip, counter timer clock. Wow, I can't get that one to come loose. That is super tight. So let's put in the original CTC. Hopefully the system will still work. Power supply on, reset, and apparently so. We're seeing little dash. So let's now put back in the original. See if I can get the PIO out. And I've got the original PIO right here. We'll see if we actually damaged these or not. I'm hoping we didn't when I had them reversed. I'd like to have the original chips in the system if at all possible. So there's the PIO, power supply on, reset. That looks good as well. 00FF, examine memory. Things are acting as they should. Finally, let's put back in the original Z80A that came with it, or the Z80 actually, not a Z80A, it was a Z80. which is this chip right here. This is a Zilog Z80 CPU, 50th week of 79. Power again, reset. And no, it's like we did damage the CPU. Well, that sucks. It's a shame when good chips die because of something stupid. And it was stupid, so we've got a... This is 30th week of 80. I probably have some older... Let me look at my Z80 CPU, see what the oldest date code I have is. First off, I want it to be a Zilog part, 83, 83, 83, 83, 82. Those are SIOs. 83, 83, 83. Is that a Mostec part? It's like 38th week of 79. It's a Mostec part. But we'll give it a shot. What's the one up above it? Same basic thing. There's another one here. 81. But again, this is a Z80 and not a Z80A. So it's appropriate to the board. Even though it's a Mostec part, it actually calls for a Mostec part in the manual. Oh wow, well, condition of those leads, I'm not even going to try it. They are so corroded. I'm not even going to attempt to clean that. And the other Mostec part next to it there looks the same. Leads are highly corroded. All these Mostec parts, the leads are highly corroded. Well, I think that kind of seals the deal. We're going to go back to the Z80A. It's less than a year newer. Its leads aren't great, but they're nothing like those Mostec parts were. Power on. Oh, it reset. It power up on its own for a change. Anyhow, I've rambled on and on. I will now do some reading to learn how to use them. Excuse me, the monitor. And we will take a look at the monitor next. But, you know, I'm pretty pleased where we got to. We've assembled it. We made it work. I had one issue that took a while to troubleshoot. There's a couple things left to do still. To recap, I still need to wire up the jacks over here for the cassette recorder. I need to get the jumper in here correctly so I can put a 2716 in there. That jumper's not in yet. Need to come up with a better way to bring power into the board. It should be interesting to play with the EEPROM programmer. I think I've got another bank of 2102s we can swap in here. That should be interesting. Give ourselves some more system RAM. But pretty pleased, pretty pleased. This would have been, just like I said, an absolute riot of fun to have had back in the day, especially with the breakout here of all the core system signals into the wire wrap area. We will look at adding in the S100 connectors as well. So lots to do with this going forward. I think it's the third time I've said it. I'm going to wrap this one up here, and I'll see you in the next video.